Welcome back, and I am very excited to tell you guys this is the last module of the course, and I'm going to sing your praises at the end of it. I'm very excited for you. But so we can finish, let's talk about data from experiments. So experiment data. The experiment must be measurable. The researcher must identify what data is needed and what exactly will be done with the data. The data should be repeatable, reproducible, and accurate. Scientists must be able to take accurate data from their experiment setup or from nature without allowing bias to alter the results. The data analysis process requires the twin skills of ordering and categorizing. Gathering data must be arranged in such a way where it is readable and readily shows the results. So this is the scientific method process. So we gather data to test predictions. We develop general theories, make observations, think of interesting questions, formulate hypotheses, and develop testable predictions. So this is the scientific method as an ongoing process. And as you can see, these are all related, and there really is no start point. We make observations, think about interesting questions, formulate hypotheses, develop testable predictions, gather data to test those predictions, and this is really what we are focusing on this slide. Relevant data can come from the literature, new observations, or formal experiments, though testing requires replication to verify results. After we do tests, we may refine, alter, expand, or reject hypotheses, and then we loop back around. So it's kind of an ongoing process for the scientific method. So now let's talk about scientific experiments. So scientific method is the method of testing an idea by designing and carrying out an experiment and then analyzing the data. Our hypothesis is a statement or question that can be tested. A hypothesis is an educated guess or insight that is relevant to the given investigation and serves as a starting point. Safety is proportional to the amount of training nurses receive. That would be a hypothesis. And the question form would be, is safety proportional to nursing training? So our hypothesis is really a statement or a question. Assumptions are statements that are taken to be fact without proof or purpose of performing a given experiment. Assumptions are needed to simplify experiments. Scientific experiments should be controlled so that all conditions except the one being manipulated are held constant. So here again is that scientific process. This is a little bit more linear. So make an observation, ask a question, form a hypothesis that answers that question, make a prediction based on the hypothesis, do an experiment to test that prediction, analyze the results. Was it supported? If it was, report the results, and if it wasn't supported, report those results, but then try again and make another hypothesis and retest. Each investigation must have an independent variable and a dependent variable and a control variable. The independent variable in this experiment is the variable the experimenter thinks is the cause. It's the variable you manipulate. As the variable is manipulated or changed, another variable called the responding or dependent variable is observed and recorded. All other variables in the experiment must be carefully controlled and are usually referred to as constants or control. The experiment should only have one independent variable. If it has two, you cannot know for certain which one has caused the effect. The dependent variable is what changes due to manipulating the independent variable. It is the effect or outcome. The control variable stays constant during the experiment, and the control group in the study does not receive the intervention. So here is a scenario. A cow is given a growth hormone and then compared to another cow that was not given a growth hormone. Both cows were weighed at 2 years. So the independent variable is what we are testing and changing. So we know that one cow is given a growth hormone and the other one is not. So the independent variable is the growth hormone, and the dependent variable, what we're looking to look at that had changed because of this independent variable, is the cow's weight. So they're weighing both the cows at 2 years to see if there's any difference. Another example is mosquito repellent is sprayed on one arm and the other arm is not sprayed. The number of mosquito bites is counted after 2 hours. So the thing that we're manipulating is the mosquito repellent. We spray it on one side, not the other. So that's our independent variable. Our dependent variable, what we're looking at as what has changed, is the number of bites. And then one grape is placed in tap water and another grape is placed in salt water. The change in their mass is measured after a day. So what are we manipulating? We are changing what type of water it is placed in. So this would be salt, the salt water. Salt is added to one water but not the other. And what we're looking to see has changed is the mass. Did it make the grape weigh more after a day? Scientific experiments' validity is the measure of how correct or adequate the results of an experiment are. A scientific experiment's reliability is if it is reproducible. This means that another person can perform the same experiment and get the same results. A scientific experiment leads to a conclusion that is often expressed as cause and effect relationship. A caused B to happen. So if we look over at this little chart, this target mark is neither reliable or valid. Let's look into this a little more. Because if it was valid, it would be hitting the bullseye, right? It would be getting the right marks, and it's not doing that. And it's not reliable because it's kind of all over the place. Now, this one is reliable. We're getting a set mark for each one that is thrown, or whatever way they're measuring this. They're always landing in this area. So it is reliable. We know every time we throw it, it's going to land in this area. It's not diverting. However, it's not valid. It's not hitting the bullseye. And this is valid because we are on the bullseye. And honestly, it seems reliable too because it is on the bullseye and it is to a set spot. All right, and that is the end of this module, and this is your last module. I'm so excited, and I just want to say I'm so proud of you guys if you've gotten through all of this. Make sure to review all of the things that you might have gotten wrong in the quizzes. Go back through and review things you're still a little unsure about, but if you've done this course and you've done the quizzes, you guys got this. You've done more prep work than most people that are going to take the TEAS, and you're going to do great. And so I will see you next time. Feel free to email me. Let me know how your exam goes. I look forward to following your nursing journey. So see you guys later. Bye.